All right, so NVIDIA just dropped a bombshell, their next-gen AI platform, Rubin. And look, this isn't just another faster chip. So what's the big deal here? Well, it seems like they're not just upgrading, they're trying to completely reinvent the entire AI data center from the ground up.
Okay, so what's the big headline number? Get this. NVIDIA is promising a 10-fold drop in cost for getting an answer from an AI. And we're not talking about simple questions. We're talking the really hard stuff, like asking an AI to analyze a company's entire financial history. A cost drop that massive, it literally changes everything.
And it's not just about running AI, it's about building it too. They're saying that to train the next massive, 10 trillion parameter model, you'll only need a quarter of the GPUs. I mean, just think about that for a second. That means smaller buildings, way lower power bills, a much simpler setup. It's a huge, huge deal.
So you've got to be asking yourself, why this crazy leap right now? What's the rush? Well, it's because we've moved way past just asking an AI for a fun fact. We are smack in the middle of what you could call AI's industrial revolution. It's become this nonstop production line for intelligence.
And that's given rise to this whole concept of the AI factory. So instead of thinking of a data center that just, stores information, picture a real factory, one that's always on, always running, just churning out intelligence 24/7. It's analyzing markets, it's doing deep research, it's powering whole armies of AI agents.
But there's a catch. These brand new AI factories, they're already hitting a wall. As they try to reason over more and more data, the power bills, the costs, the sheer complexity, it's all just skyrocketing. And think about it, even a tiny little inefficiency becomes a monster of a problem when you're dealing with trillions of pieces of data.
Okay, so how is NVIDIA planning to tackle this? Let's dive right into their solution, the Rubin platform. And I gotta say, it's really less of a simple upgrade and more like a whole new philosophy for how you even build these AI factories in the first place. The core idea here is something they're calling extreme co-design. So what on earth does that mean? Well, basically, instead of just designing a CPU over here and a GPU over there and, hoping they play nice together, they designed everything at the same time. We're talking the chips, the networking, even the cooling system, all of it, so it all functions as one single perfectly integrated machine.
And this quote really just hits the nail on the head. They are not thinking about a single computer anymore. No way. They're thinking about the entire data center rack as one single giant cohesive supercomputer. That is a massive mental shift.
So, how in the world do you actually make an entire rack act like one single machine? Well, the answer is kind of wild. You design 6 brand new purpose-built chips that are all engineered from the ground up to work in perfect harmony with each other. Now, what's so cool here is how it all breaks down into a team. You've got the engines, the Vera CPU, that's like the data coordinator, and the Rubin GPU, which does all the heavy lifting. Then you've got the communication system, or the fabrics. NVLink for that super fast talk inside the rack, and then the SuperNIC and Ethernet switch to connect all the different racks together. And get this, there's even a manager, the BlueField DPU, whose whole job is to run the factory floor.
All right, first up is the Vera CPU. You can really think of this as the data engine. And just look at that memory bandwidth. It's more than doubled. Now, why does that matter so much? Well, it's all about shoveling data into the GPUs fast enough to keep them busy. It's like you never want your star quarterback waiting for the ball, right? You want to get it there instantly.
And here we go, the star of the show, the Rubin GPU. The big headline is that 5x jump in inference power, which is just insane. But what's just as critical is that the memory bandwidth has almost tripled. It's that combination, that raw power married to a massive data pipeline, that's what lets the AI really think through those super long, complex problems.
But look, all that raw power is useless if you can't move the data around. It's like having a Ferrari stuck in traffic. That's why these new interconnects are so important. You've got NVLink 6, which doubles the speed inside the rack. That lets all 72 GPUs talk to each other like they're one brain. And at the same time, the new Spectrum X Ethernet doubles the speed for connecting all the racks together so you can build out the whole AI factory.
Okay, so we've seen all the individual pieces. Now let's see how they all snap together. Kind of like Legos, to scale up from a single chip to a massive city-sized AI factory.
The whole system is it's brilliantly modular. It starts small with the superchip, then you combine a couple of those into a tray. Then you stack 18 of those trays together and boom, you've got the NVL72 rack. That's your first single liquid-cooled supercomputer. From there, you just link those racks together to build out your entire AI factory. Simple as that.
All right, so this brings us right back to where we started, with those absolutely massive numbers.
What does all this fancy architecture, the co-design, the new chips, the modular scaling, what does it actually mean for real-world AI? Well, it all comes back to this, a potential 10-fold boost in performance, specifically for those really complex, multi-step AI tasks. So we're not just talking about getting the weather forecast a little faster. No, this is about letting an AI actually think its way through a really hard problem, step by step, in real time.
And that, of course, totally changes the economics of AI. When you slash the cost of each thought by up to 90%, it makes this advanced AI reasoning so much more accessible. I mean, what used to be a super expensive luxury feature could very soon become standard practice for everyone.
And hey, you don't have to take my word for it. You've got industry leaders like OpenAI's Sam Altman pointing to exactly this kind of progress in the underlying infrastructure as the key that unlocks more capable AI. It's simple, really. The hardware is what allows the software to keep getting smarter and smarter.
And that really leaves us with one final, pretty provocative thought. When the cost of a foundational technology, like AI reasoning, drops this dramatically, the result is never just doing the old stuff a little bit faster. No, it unlocks entirely new kinds of applications, things we literally haven't even imagined yet. So the real question isn't just what can Rubin do, it's what are we all going to build with it?